Okay, now we're going to talk about solving rational equations. So here's an example of a rational equation. And so the first thing we're going to do is we want to factor out the denominators completely, because we want what our goal is to get rid of the fractions so that we're just having a polynomial equation. Okay, so what we're going to do is we're going to factor this anyway, this one, so that we can have all of the factors, and then we can basically multiply by the least common divisor, and then that'll get rid of all the denominators if we do that. Okay, so let's factor this. So this is factorable. Okay, so let's look at factors of -8 that will give us -2, and that is 2 times 4. So that'll be so the negative here means it's opposite signs. The larger factor is negative, so that means the 4 is negative. So it'll be factored into x minus 4 and x plus 2. All right, so now what we're going to do is we want to multiply by the lowest common divisor. Okay, so the lowest common divisor would be this, right? Would be this factor here, because this is missing an x plus 2. So if we multiply the top and the bottom by x plus 2, and if we multiply the top and bottom by x minus 4, we'll get a common divisor. So the lowest common divisor that we can get is going to be the x minus 4 times x plus 2. Okay? So if we multiply everything by this, then all of the factors, or excuse me, all of the denominators should cancel. So let's do that. So watch what happens. So I'll just do it out longhand so that we can see it. Okay? So we'll do x minus 4 times x plus 2 times 2x all over x minus 4 minus x minus 4 x plus 2 times 3. And then we have oops. Sometimes I write too big. Okay. So all I did was to go from here to here, was just multiplied everything by the LCD, the lowest common divisor. Okay? And so now you'll see that the denominators all cancel out. And so now I've got an equivalent equation that just involves polynomials, right? So it's going to be x plus 2 times 2x minus x minus 4 times 3 equals x squared plus 14. And now what I can do is simplify this and set it and make it into a polynomial equation and solve. Okay, so if I do that, that'll give me what? That'll give me 2x squared plus 4x minus So if I distribute the minus, so this will be minus x plus 4. But if I distribute the 3, this becomes 3x, this becomes 12, right? So it'll be minus 3x plus 12. So minus 3x plus 12 equals x squared plus 14. Okay? Now, I'm going to keep the top part. Because I want to show you guys something at the end here when we're finished. So now, if I move everything over, so I'm going to subtract x squared from both sides, right? So I'm going to subtract x squared and subtract 14 from both sides. Okay? So now what that's going to give me, obviously these are going to cancel out, so I'm going to get 0 over on the right. This is going to give me x squared plus 4x. Oh, let's combine like terms. This is just going to give me x. 4x minus 3x is just x. So I get x squared plus x, and then 12 minus 14, that gives me a minus 2, is equal to 0. And now we can factor this. So here, 2 factors of negative 2, they add to 1. And that's going to be 2 times negative 1, right? So that'll split up into x plus 2 and x minus 1 is equal to 0. Okay? So now we get x plus 2 is equal to 0, or x minus 1 is equal to 0. So we get x is equal to negative 2, or x is equal to 1. Okay? So those are our 2 possible solutions that we just solved or came to, obtained. So now we have to go in and check. Now here's where you have to be careful. Now remember, with rational expressions, they have restricted values, right? So if we look at this original equation, and of course this was factored into x minus 4 times x plus 2, if you remember, okay? Which is the same as these, right? This one and this one. So now what we notice here is if we look at these denominators, we have a couple of restricted values. Here, x cannot equal what? 4. And here, x cannot equal negative 2. But negative 2 is one of the possible solutions. So this one is an extraneous solution. Okay, it turns out to be a restricted value, so we cannot use this. Because if we plug it in here, we'll get 0 in the denominator, and we can't do that. So this is not going to be a solution. So our solution is going to end up with x plus 1, or x equals 1. And again, if you take 1 and plug it into the original equation, you get what? You get negative 2/3, right? So we're going to plug in 1. You get negative 2/3 minus 3/3 equals 15 over what? So this will be negative 3 and 3, so negative 9. So this would be 15 ninths, right? Okay, so if you make this into ninths, right, this will be -6/9. This will be 9/9, right? And so if you add the left side here, you get -15/9, and you get a true statement. And so you just verified that x = 1 is indeed a true solution. All right, that's it.